Okay, let's take a look at doing some input now. We're going to use the keyboard to move an object around. I want to keep hold of the 3 scripts from last time. We are going to use them later on. They're going to be helpful when we come to build a game. So don't get rid of any of them. But I have adjusted the scene. It's now just a single cube that doesn't have any of that prior code on. And we're going to make a new script now to control it. So let's create C# script and call it cube controller. That's what it's going to do. It might as well have a suitable name. Fire that up, and let's just strip away some of the stuff we don't need. We don't need the start function or the comments, so let's get rid. And we're going to use the update function. First of all, we're just going to wait for a single key press and just make sure that we can do that. And before we actually use the input section, we need to ask a question. We're going to use an if statement. So this is the first time this has appeared in this set of videos, and it's the keyword if, which lets us ask a question and then respond based on the answer. That needs a set of brackets, so 2 normal brackets, inside of which we put our question, and then at the end we have another set of curly brackets, and they wrap the response. So if the answer to this question is yes, the code in these brackets will happen, will execute. So let's put the question in. This is where we're going to use Unity's input class. So start typing input, select it, and then dot, and we want to use the get key down function. So as soon as you can see that, use get key down, and that's a function, so it needs its own set of brackets, and notice straight away it detects that it needs a key code, so it's actually suggested we use a key code, which is quite good, and it's what we want, so we're going to press enter, followed by a dot, and now we get to pick a key. So you can choose any of your keys. I'm actually going to use the space bar, so I'm going to start typing space, and it will prompt me, just choose that, then close the brackets for the get key down function, make sure the if is closed, make sure that the curly brackets are open, and drop down a line. And that's now a complete if statement. So it says if the space button is pressed, do something. And at the moment we don't actually have the something. So let's just debug.log, and in brackets let's put space pressed. Semicolon at the end, save it up, jump to Unity and drag this new cube controller onto the cube. Hit play, make sure you've got your console visible, and press the spacebar. Ta-da! We have space pressed, so that worked. Notice as well it was just when it was first pressed. If I hold the spacebar in, we don't get any more. If you do want to get more, it's just get key instead of get key down. That would, let's show you. Save that, jump back, run it again, and now holding space spams the console. So that's the difference there between get key down and get key. Let's adapt it slightly. So the last video we spent a lot of time looking at moving an object, so we might as well make some use of it. So instead of just simply putting a message out there, let's move the object. So let's do transform.translate, and let's move it upwards. So we'll go 0, 0.1 in the y-axis with an F, 0 in the z-axis. So that should move 0.1 of a unit up for every frame that the spacebar is held. And there it goes, off on its merry way. So far so good. It's not very useful though. Let's try and tailor this to be more like game controls. So we could swap space for up or up arrow, and we could swap the Y movement to be Z movement instead. So let's have 0.1F in the Z axis. I probably should have saved the script first, so that's not going to be very good. Make sure it's saved, jump back, and hold up, and we go off into the distance. Very good. And we also know how to rotate as well. So now we know how to ask questions, we know how to move, we know how to rotate. You can probably piece a lot of that together. So we could put if input dot get key, and then the key code is going to be, let's say, left key, left arrow. Doing it end of the if with the curly bracket, and we could do transform dot rotate. rotation, rotate. And when we press the left arrow, just to show you visually, let's jump to Unity, select the cube, and we can see with the rotation tool selected, we've got 3 coloured circles going around it, and we want this green one. So let's grab it. This is what we want to happen, this sort of rotation. So we can look over in the transform component, just as we're playing around real time, we can see that it's actually the Y rotation that's changing. So we need to affect the Y rotation to do this. So let's jump back to the code, and we don't need to rotate in the X. Let's rotate maybe -5 degrees in the Y, so we want to go left. And let's not rotate in the Z. Let's give that a try. So we can move forward, we can rotate left, we can move forward, and because we're translating, it actually moves in the direction it's facing. So that's pretty cool. And I'm sure, looking at that, you could dream up a way to keep going and add more and more complicated if statements to get lots of movement. However, there's a much easier way to do it. So I'm not actually going to keep pasting these ifs. I'm going to get rid of them both. It's good that we've done them. We now can do if statements and we know that our keys are working, but let's get rid. There's a much easier way. And it's because Unity has a very intricate input system. I'm going to show you just somewhere to look for reference here. Back in Unity, if you go to Edit, Project Settings and choose the Input option, your inspector will update. It's a very minor update, it just has one word. If you click on that to expand it, it will show you a list of words that you can use to query certain key presses and combinations of key presses. And the ones we're interested in at the moment are horizontal and vertical. So if we just drop down the horizontal one, for example, we can see in here it's got a name. So we've got an input manager that's got a load of axes, not axes as in weapons, but we can define axes. So for horizontal and vertical make perfect sense. For the up and down as the vertical, left and right is horizontal, and the buttons reflect that. So here we can see we've got a negative button, and what this actually does is returns a negative number when the left key is held, and the numbers are always between -1 and 1. Sorry. So left would be -1. Positive button right, when you press the right key, it would give us 1, and we can use that to rotate instead. Instead of querying certain key press or doing individual keys, we can actually check an axis. So we can ask for the state of the horizontal axis and just rotate based on that, and that's what we're going to do now. So let's flick back to the code, and let's just do transform dot rotation, rotate, and then in brackets, we don't want to rotate in the x-axis, but we do want to rotate in the y, and this time we want to do it based on the horizontal axis. Let's do input dot get axis this time, and then in the brackets of that function we're going to type the name of our axis, which was horizontal with a capital H, and then close the brackets, do a comma, and put 0 rotation for the z-axis. And that saves us a lot of time and effort doing if statements and checking individual keys, because not only does that work with the left and right keys, it will work with the A and D keys, it will work with the left analog stick of a joypad if you plug one in. So it's very handy to use Unity's input manager. Let's give that a try. So left and right, now rotate that cube. Let's take it a step further and let's actually move based on the vertical axis. So underneath, let's transform dot translate, 0 in the x-axis, 0 in the y-axis, and then let's use input dot get axis vertical. Make sure you spell it correctly, make sure you use the right capital letters, make sure you close all your brackets, semicolon, save, flip back to Unity. So now we should be able to move around with up and down, which we can. It's very fast, but we can do it. And we can rotate left and right. And because translate applies based on your current state, the object will move in the direction it's facing, which is very handy. Let's just tinker with the numbers a bit to make this a bit smoother. So currently the rotation's too slow. So let's multiply our horizontal axis using a star symbol by a certain number. Maybe we want it 5 times quicker for the rotation. And the movement is too fast. So let's multiply our vertical axis by a small number, so 0.1f for 10% of the movement speed. So we're going to rotate 5 times faster and we're going to move 10 times slower. I'm not sure I saved it, but let's see. Yeah, there we go. So we rotate pretty quickly now and we don't move as fast. And it's a much better feeling movement. I could imagine that being a character in a game already. Little cube in search of his shopping. He's lost his bananas. Coming out Steam Greenlight next week. So there's movement. Just to jazz it up a little bit more, let's take our main camera. So we've got main camera that currently is very static. Let's grab hold of it in the hierarchy and just drag it into the cube. So it's now a child of the cube and it's going to follow it around. Because we've done that, we've covered that before. We put a sphere into a cube earlier and we saw that they stuck together. And that's the same approach here. So now the main camera is going to follow this cube around. Now the exploration, looking for those bananas, gets all the more immersive. I feel like I'm in that supermarket. Okay, so we've got rotation, we've got movement, we've used the keyboard. Let's press forward a bit now. Let's actually rotate the camera using our mouse instead. And that will give us the ability to strafe with the left and right arrows instead. So we can chop this, this horizontal axis out of the rotation. Let's cut that from there. We're going to use something else. And in the translate, let's actually move in the x-axis based on that horizontal axis. It's getting confusing because we're using axis multiple times, but never mind. Because we've got the actual axis from the input manager, and then you've got the movement axis of X, Y, Z, or the rotation axis of X, Y, Z. But something you're just going to have to learn to deal with, I'm afraid. Notice I multiplied the horizontal axis by 0.1 as well, just to keep the movement speed consistent. That could be a variable. You might want to make a variable up here for movement speed that you could control outside in Unity. But let's do the mouse bit. So the rotation up there, transform.rotate, is now going to be based on the mouse. And if you were on the ball earlier, when we were in the input manager, you might have clocked the mouse X and mouse Y axes. Just notice the way they're written, there is a space there. So mouse X and mouse Y actually have spaces. So let's jump in and let's do our Y rotation based on the X of the mouse. So side to side X movement will rotate us in the Y axis. So let's just check the Y axis here, it's this green one. So side to side of the mouse, as I'm doing here, is going to affect that rotation. It seems weird using the X to affect the Y, but it's what we need to do. So let's do input dot get axis brackets quote mouse X, close quote, close bracket. Don't need that semicolon I accidentally typed, and let's save that. Back to Unity, give it a go, and hopefully moving the mouse, yeah, rotates our object. And now because we've changed the horizontal axis to be side to side movement, we can actually strafe around the camera. We can move forward and backwards, and we can strafe. Those bananas don't have a chance. Okay, now looking at that, you can probably hazard a guess at how we could do up and down movement. So let's go ahead and do the obvious bit. Let's change the X rotation, definitely the X rotation, to be input dot get axis brackets mouse Y. It seems like the logical way to go about it, doesn't it? And you're right, it is logical, but if we run it now, we get some very messy results because the rotations, it's making me sick already. The rotation's been applied based on the current state of the cube, so rotating around the x-axis is very different once you've already rotated in the y-axis. And I'll demonstrate that visually. So here, just take the cube in the editor and if we grab the red circle for X rotation and rotate a little bit, notice that the Y-axis is now different. Rotating around that will now have a slightly different effect than it would have done beforehand. So our Y rotation doesn't work when it's partnered up with X rotation like that. And the reason is, it's not showing it correctly here, it's because we're currently applying this rotation based on the local settings of that object, although it says global. If I just flick to local, there we go. We are rotating based on the object's current setup. If we swap this to global now, watch what happens to the tool when I click. Snaps back to give us consistent world rotation. So even though the cube's on a weird angle, the X, Y, and Z rotation tools have stayed consistent, and that's what we need in our code to make this mouse rotation make sense. Just going to undo some of that rotation. There we go. And in the code, we just need to, one of the axes we rotate around, our actual Y-axis, needs to be based on global positioning rather than the object's current state. So we're actually going to strip this out and have two of these lines. Let's get rid of the Y rotation here. So chop that from there and put 0. So there's no longer any rotation in the Y-axis. I'm going to save that and just make sure that the X-axis rotation still works. So we can still look up and down, that's fine. We can still move forwards, backwards and side to side, although we are sort of flying, which is a bit annoying, but it's working. Let's flip back to MonoDevelop, and we're going to copy this whole rotation line, paste it underneath, and we're going to add a little bit of information to it. We also need to fix it so it's actually doing the Y rotation. So let's just delete that bit. We don't want any X rotation. We do want Y rotation, but we don't want Z rotation. We want input dot get axis, and this is going to be our mouse X for the Y rotation, times 5 again. So that's now as it was, but just stripped out so it's done. Each rotation is being applied separately. And then finally, after this Z rotation, we're going to do another comma, and it's going to prompt us for a space. So what sort of space do we want to apply this rotation in? If we press enter, do a dot, it will prompt us. So I've got a choice of self, which is the default, which is why we've had the mess so far, or world, which is going to be much more manageable in this case. Let's use world. Save that. And now our Y rotation isn't based on the object's position, it's based on world scales, world rotation. So let's run it. And the X-axis works fine, but now when we move side to side, we don't get that horrible sort of leaning, tilting. We just get what we expected. We can still fly because obviously we're rotating to look up. Our translate tools are based on the way we're facing. So you could maybe make a spaceship sort of game. Flying bananas in a supermarket. You can have that idea for free. It's $1 million idea. But it works, so you could see how you could make a sort of free-flying dogfighting game or something there. That'd be pretty cool. Or upside down. And that's just some of the things you need to be aware of when you start working with different axes. I think I'll probably leave this one there. And in the next one, we're going to look at actually affecting the physics. So at the moment, we've just moved the object using translation stuff. We're going to look at actually working with rigid bodies in code in the next one. So I'll see you there.